So I pulled up the data set for 7.2.3 off to the right side of the screen here. You want to code this so that we can sum it up real quick, and that way we don't have to count each and every one. So type equals if in cell B2. Type equals if, open a parentheses. We want to check to see if A2 is equal to yes. Actually, I don't know if we need the quotes. Here, I'll test that. If it equals yes, put a comma and then put 1. And if it doesn't equal yes, if it's no, then we're going to put a 0. So let me try to zoom in on that code. I don't think I can. So there's that code in case you need to pause the video and look at it. So if you drag that, it's giving us a 1 when we hit yes. So drag that, and you can do this in Google Sheets too. Drag that all the way down. That counts up all the yeses so that we don't have to try to do that by hand. And then we can just find out how many yeses there are by finding another empty cell, type equals sum, go from B2 to B whatever, B51, and then close that parentheses. So there, we added them up real quick. There's 22. So now we know our sample proportion. It's 22 divided by our sample size, which, I mean, they said a random sample. Oh, I'm on sheet 4. Okay, well, if you got sheet 4, that's what you got to do. I'm supposed to be in sheet 1. So same thing. Equals if this if A2 is equal to yes, then I'm putting a 1, or else I'm putting a 0. Click and drag that, and then same type of thing. Equals sum B2 to B76, I imagine. Yep. Okay, there I added them all up. There's 32 there. So it's 32 divided by, oops. 32 divided by 75. That's 0.42666. So we'll just round that off at some point. They want us to construct a confidence interval. So now we have the sample proportion. We can construct that confidence interval using the formula. And we have to, unless they tell us, we have to estimate p hat. We have to estimate p with p hat. So we're going to put a hat on here. So 0.4267 plus or minus. Now Z star, you can just scroll up. They have a table for you. Z star for 95% confidence is 1.960. And that's times the square root of p hat. And then it's 1 minus 0.4267 divided by the sample size. And this one, there's 75 people. Okay, so here we can use our calculator. You can do 1 minus 0.4267, do the parentheses first, multiply that to 0.4267, divide by the sample size, and then take a square root, and then multiply that result to the Z star that we had out front. So that's our margin of error, 0.1119. So that means we need to do it twice. We need to do 0.4267 minus our margin of error, so 0.314762, and then do 0.4267 plus our margin of error. That gets you your lower and upper bound. Okay, so I think that's what they're looking for here. I think there's one other question. 0.314762, and then 0.5386. I didn't say how many decimals. So the manager can say with 95% confidence that the true population proportion is between these two numbers. This is just the same two numbers up here. Let's see, it marked it wrong. No, I have that right. It marked that wrong. And I have that right too. I guess the only difference is I didn't carry out my decimals. Did they say anywhere how many decimals they want? So my numbers are right. I just rounded them. I mean, I cut them off at some point with decimals. They never say how many decimal places they want, so that's a pretty silly reason to mark a student wrong. Okay, so there's the lesson learned. Oh, I know why. No, it's my fault. Look, upper bound and lower bound. I switched those. I put my lower bound in my upper bound in my lower bound. So that was too critical of me of Zybooks. So just watch out for that. Usually you say lower bound first, then upper bound second, and I was just going too fast. So the lower bound is the lowest number. That should be 0.3147. Okay, I think the rest of them are going to be the same type of thing. So I'll leave this for students to do. Like if you get sheet 4, you already get to see me calculate that, but it should be the same process.